Hi, everybody. This is Stan. Stan is 70 and built himself a retirement home outside of San Diego. Fortunately, his home didn't burn in the devastating 2017 and 2018 wildfires. However, his insurance company refused to renew his coverage, and the only other option that he could find charged him $24,000 a year with a $100,000 deductible. And Stan's not the only one. There's many articles that discuss many people that go through the exact same problem as Stan, hundreds of thousands throughout California. So why is this happening? Well, after the 2017 and 2018 wildfires, insurance companies came to realize that the third-party data models, the wildfire models that they were buying, were incredibly inaccurate. Because of this inaccuracy, they decided they simply can't write anywhere near wildfire areas because they don't know which homes are low risk and which homes are high risk. This creates a huge opportunity for a company that does understand that risk. Let's go ahead and take a look at a set of homes that burned in 2017 and 2018. And let's look at the model that most insurance companies buy, the industry-leading model. And let's see how that model rated the risk of these homes before they burned. As you can see, they incorrectly thought that these homes were at a low risk of burning. And again, all of these homes burned. Because of this, insurance companies simply decide that they'll stay away from anywhere near wildfire region. They don't know which homes are going to burn, which homes are not. Delos takes advantage of this opportunity. We're launching a property insurance company that writes insurance specifically for low-risk homes within catastrophe regions. We're starting with wildfire, and we'll handle hurricane next. But the key is the fact that we have created our own proprietary wildfire models that vastly outperform the models that are available in the industry. We use this model to be able to understand what areas are low risk and offer insurance to homes that other insurance companies simply would stay away from. On top of this, our policy comes along with an active risk mitigation service. We reach out to every homeowner once a month, tell them exactly how their risk has changed and the top things they can change about their home to protect themselves from wildfire. Okay, let's go back and look at those homes that burned in 2017 and 2018. This time, let's see how the Delos wildfire model rated the wildfire risk of these homes. As you can see, we correctly predicted that these homes were likely to burn. We use this accuracy to understand which areas are less likely to burn, to go into those areas and build a profitable portfolio of homes. And we're not the only people that understand the value of our model. The rest of the insurance industry also sees that value. We've sold an analytics side product to 3 different insurance companies in California. Okay, how are we able to understand, to create a model that performs this well? Well, for that, let's look at our team. I'm Kevin. I have experience in aerospace management and a master's in aerospace engineering from Stanford. This here is Shanna. She's a physicist with experience in predictive modeling. David and Max are wildfire science professors, some of the top in the world. They have co-created the California Firefighting Department's wildfire model. Chow is a PhD in actuary. Paul ran home insurance at Mercury for 10 years. And Tom has sold over $1 billion of insurance in his lifetime. Let's take a look at our model. There's many different data input layers that go into our model. This includes temperature, wind, satellite imagery, a variety of micro prediction models. That includes a fire weather model, wildfire simulations, as well as a probabilistic ignition model. All of these are layers that go into an AI algorithm. That AI algorithm is trained on decades of fire history and outputs a fire risk map. That risk map tells us where to write insurance, but also how to price that insurance. Now let's go ahead and move to the demo. I'll show you how it works. So Shanna's going to pull up our website. This is where a homeowner or an independent agent will come to get a quote. Put in an address, then put in information about themselves and their home. Once they do that, they'll get this screen. We're working to get a quote to pop up on that screen. But let's look at what goes into creating that quote. Shanna's now going to pull up our map modeling software and show you the data input layers like the satellite imagery and the micro prediction models. Again, those go into an AI algorithm and output this. This is our wildfire risk map of California. Those 2 dots that you see there are addresses that have been put into the website. They immediately get imported in that table. as well as the information that's put into the website. And the risk score from the wildfire risk map is immediately appended. That goes to our actuarial model, and that actuarial model outputs a price that gets posted on the website. Back to the presentation. There are 36 million homes in America that are high risk for hurricane or wildfire. We see half of those as lower risk than the rest of the insurance community. That's the market created by our modeling. 18 million times 3,000 creates a $54 billion premium potential. We're launching as a managing general agent, or MGA. It's one of the standards in InsurTech used by Hippo, Metromile, and many others. The idea is the MGA writes the insurance carrier pays out the claims. We're selling through independent agents. We actually have 5 agencies that have invested in Delos. They have a combined book of $150 million in California. We are currently looking for insurance carrier and reinsurance company partnerships. If you are one of those companies, please come talk to us. Thank you.
All right, judges.
So is any of the data that you're ingesting into your algorithm proprietary?
Yes. So some of the data we're using is from government, but we have quite a few layers that are proprietary submodels that our team has been building over years. And so a lot of, those data sources, they include some simulations, et cetera, that we've done on our team.
Okay.
You mentioned there were 36 million homes at risk, whether it's fire, hurricane, and 18 million of them are lower risk, where maybe they wouldn't have gotten insurance before, but you would be able to provide them insurance.
Exactly.
Ultimately, if there's a high-risk home, there's just no one who's going to insure that one? Because at this point, you're really bifurcating the market to be able to show who isn't going to be getting insurance.
Yeah, there's plenty of homes we will say no to. There are homes that are too high risk, and it's not a good financial decision. We want to help people, right? The entire idea was we want to reduce loss through sharing information about people's risk. And for a lot of people, we'll be able to do that and provide an insurance policy. But you can't insure every home. That's just not smart.
That was going to be my question, is trying to understand the mission of the company. Is the mission to get more coverage for more homeowners, or is it to increase profitability for carriers? Because I have the same question, which is, if you identify a low-risk house as high risk and a high-risk house as low risk, it's a shell game, right? You're just moving the risk from one house to another. Do you think it's net adds in terms of coverage, or is this really about higher profitability for carriers by sharper underwriting?
It's a great question. Yeah, the fact that we are able to produce a profitable portfolio sort of shows the advantage of our model. But the reason why we got into this, so Shanna and I started this company originally to reduce wildfire losses. And we found that the only way to create a large profitable company that gets enough revenue to sort of continually turn the wheel of innovation and understanding of wildfire. Wildfire's changing, right? And so you have to constantly update models, understand the new peril. We wanted to be able to take these large models and explain to each individual what they can do to protect themselves, right? When a climate scientist says the atmosphere is warming 2 degrees, what does that mean to you when you leave your home every morning? Mm-hmm. We wanted to be able to take this data that we were gathering and use it to impact each individual. For people that live in wildfire areas, we are giving them the information to be able to protect themselves. And there are homes that are too high of risk, but we're going to ensure the ones that we see are lower risk to be able to create the company we need, and then give them this active risk mitigation service so they can, as a population, slowly move homes towards wildfire hardened in California and in the rest of the United States.
So I have 2 questions. They're somewhat related.
Yeah.
Can you talk about the competitive environment? And 2, in not making this data public, do you feel like you have a moral dilemma? And this kind of goes to Brian's point. Do you want to educate people on where they're living and what the risks are?
But the moral dilemma question is something that we've talked a lot about internally. We're very close to CAL FIRE, the firefighting department, and so we've had a lot of conversations about that. Since I'm on that, I'll just address that quickly. Our professors have worked in NGOs and civil governments for their entire careers as academics. And while it's a very noble effort, they've created amazing technology in order to really have the resources to be able to change people's homes, help them with things. Being private in some way is necessary. However, we have a close relationship with CAL FIRE, and we have been in a lot of discussions about new construction in wildfire areas that we can participate back by showing them exactly the best way to construct their homes, and then we'll have an opportunity to ensure these homes that were built in the correct way. So it's an advantage for both of us. The competitive environment. So after these 2 years, almost every insurance company really did pull out. There's a few non-admitted carriers that do right. The average premium currently for a non-admitted policy is $8,000 per home. The average in California is $1,000 for non-high-risk homes. And so those are very sort of old school, been around for a century type of companies that write all types of high risk. We are taking advantage of new data, new technology to be able to really focus on wildfire and hurricane. We have some hurricane models that we've already gotten under works, to be able to understand that specific peril and make it a profitable portfolio in that area.
We have time for like a really quick question if anyone has one. We good? All right, give it up for Delos.
Thanks, guys.